Hello and welcome to the show, everybody. My name is Nick Larson. Today is June 21st, 2019, and it's right at 12 o'clock. Guess what? Sometimes I do start on time. Not all the time, but this week, well, today, yeah, I started on time. Just to get started real fast, I'd like to give a big shout out to Binary Chef for the follow. I really appreciate that. It means a lot. It really does mean a lot. Thank you so much for that. And then second, we posted our blog post over the weekend. This is what it looks like, which is awesome. You should read through it if you have a chance. I would really appreciate that. And I'll drop a link in the chat here. You can find it on my website. That's culturaldevelopment.com. And if you go to the blog, it's the top one. Okay. Yeah, this is a really introductory read. As we go through this kind of stuff, I am intending to make this like a series. We've gotten the first one out. I feel really good about the second one. There's only a few changes. I've got some ideas about how I want to present the information. Oh, I always do this. I literally always do this. I never update. Update the information. I have got to get on top of this. I never update the stream title before I start the stream. It's like I just need like a to-do list that I start reading before I get on the stream instead of after I get on the stream. Okay. Yeah, so please read through the blog post. If you have any questions, feel free to ask. Send me an email or send me a tweet, whatever, and I'll get back to you and answer your question as best I can. That would be awesome. I also want to throw a big shout out to Hugo Dahl one more time for actually helping me get through the project and helping me sort of clear up a lot of the language in the blog post as we were working through it. Okay. Yeah, it was fun. The next one's going to be even more fun, where we make it almost twice as fast by doing really trivial stuff that you can use in basically every project that you have ever written in C#. So look forward to that one. Should be out early next week. I think I'm going to spend some time this weekend writing it. Today is Friday, and I am going to take a play day, so to speak. Today I want to do something new that I have never done before. I want to implement a Monte Carlo tree search. That's what I'm hoping to do today. Now keep in mind, I have literally never implemented one of these before. I have been super excited about it. Oh wait, no, I take this back. Have I implemented one of these? No, I've never implemented one of these. I have implemented the not like a full game, but the lever pulling thing. Oh god, I'm never gonna remember this. Oh, the multi-arm bandit problem. I have implemented that before, which is like one step of this, but not the whole algorithm. What I want to do is basically make something that can beat us at tic-tac-toe, or at least tie us. And then after that, we're going to ramp it up pretty quickly to something more interesting. I don't know which game just yet, but hopefully we'll get it done today because I'd really like to do that. And you're going to watch me like literally go from having no knowledge to hopefully getting something up and working. And that's the goal for today. I'm just getting dinged like crazy on my watch, which is also crazy. Okay. Monte Carlo tree search. Again, I know nothing about this. You're watching me learn in real time. All right, I know the general concept. So the general concept is you are at a decision node and you have to make a decision. So what you do is you basically run a simulation and you go the branch that ends up winning the most. The way that you select the branches that you want to go explore next, that is the interesting part of Monte Carlo, and there's a couple of ways to do this. The most trivial way is run this one 1,000 times, run this one 1,000 times, run this one 1,000 times, and then just choose the one that basically when I say run this 1,000 times, I mean in the idea of tic-tac-toe, choose the next move, run out 1,000 games randomly, entirely randomly. Do this for every possible successor move, and then choose the one that performs the best over all of those. And that would be the selection. However, that would be what I'm guessing is going to end up being pure Monte Carlo. And then there is exploration and exploitation, which is what I'm more interested in, which does a sort of principled approach to choosing. I should not do writing stories. I should. Monte Carlo. Hey, what's up, Hugo Doll? Um, yeah, man. I don't know. Were you here a minute ago? I was just talking about the blog post. I do want to give you a huge thank you, man, for all of the help that you gave me along the way. Um, God, it came out a whole lot better with the help that you gave me. Both the project as I was working on it, as well as the text of the blog post here. This is the first in the series. Came in when you were talking about tic tac toe. Okay, yeah. Well, so huge, 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 huge big ups to you, man. I really, really appreciate it. I got a fair amount of traffic on it for having it be my first blog post in like literally 2 years. I think it was literally 2 years. Let's go take a look real fast. 2019. Oh gosh, that's bad. That's not supposed to be on there. I'm just gonna put that on my to-do list. I'm not gonna actually, because that's just like a giant, like that's all the notes. That should not have made it to the live blog. Oops. But anyway, yeah, 2019. So not quite is what, 20 months? Yeah, 20 months. So for the first blog post in 20 months, uh, yeah, we got like 350 people to look at it yesterday, which was pretty cool. And for a blog post that literally has nothing interesting as far as like how we went about analyzing stuff and making decisions to actually improve the code, I feel like that's a pretty good start. I am really looking forward to this next blog post where like we take this 50 lines of code and basically leave it as 50 lines of code and just change a few things, and all of a sudden it's going to be like twice as fast. Oh, well, yeah, okay, sure. I don't know. It's more of like the story, right? That's what I'm going for. I'm trying to practice writing, even technical writing, as like stories. It's much more interesting to read a story and be like, oh, that's how they did that. Oh, that's why they did that. Oh, this is what I would have done instead. Oh, that sort of a thing is like makes for a really fun read as opposed to like, this is why you do this because I said so. This is why you do this because I said so. You know, I get tired of reading those. It's a good setup for the problem at hand. What comes next? Yeah, absolutely. And what comes next is a lot of fun in this one. I mean, it really was a lot of fun. Like getting 50% perf improvement basically by doing trivial stuff that anybody could do and use in basically every project that they work on. All valuable. All valuable. Okay. But anyway, today, Monte Carlo tree search. Gonna play a game. And I think we're gonna do the absolute random version first, and then we'll do the more and then we'll do the more principled approach. Again, you are watching me learn all of this in real time. I have never implemented any of this before, so let's give it a shot. Let's give it a shot and see how it does. Um, we're gonna need some code. We're gonna need some new project. Oh, I know why this is happening. It's in this YAML file because I was doing something dumb. Uh-oh, where's my YAML file? Config.yaml, and there was a thing in here about like rendering. Oh man, where is it? Rendering drafts. Render drafts, false. Okay. Hexo deploy generate. Don't render drafts. Ha! Push. Okay. Now let's go and say close my window and create a new folder. File, open folder, culture of development. Let's call this Monte Carlo tree search. Of course it doesn't exist. I'm trying to create it. New folder. Monte Carlo tree search. Monte Carlo tree search. Let's call it what it is. Monte Carlo tree search. There we go. Boom. Okay, that's the one. So much for not fixing it out. Man, here's the thing. If I had not actually fixed it right then when it popped up, I would never have fixed it. And people would have mentioned it and I would have been like, whatever. Let's see if it actually fixed it. Blog. Yay! Alright, it did fix it. Okay, we're not going to worry about this anymore. We're going to move on and start learning real stuff. Yeah. I'm like so bad about it. Like so bad about it. Okay. Monte Carlo tree search. Complete random. Oh, wait. We should read about this. Okay. The focus of Monte Carlo tree search is on the analysis of the most promising moves, expanding tree search based on random sampling of the search space. The application of Monte Carlo tree search in games is based on many playouts. In each playout, the game is played out to the very end by selecting moves at random. The final game result of each playout is then used to weight the nodes in the game tree so far so that better nodes are more likely to be chosen in future playouts. Okay, well that seems more interesting. The most basic way to use playouts is to apply the same number of playouts after each legal move of the current player, then choose which move led to the most victories. The most basic way to use playouts is to apply the same number of playouts after each legal move of the current player, then choose the move which led to the most victories. The efficiency of this method, called pure Monte Carlo game search, often increases with time as more playouts are assigned to the moves that have frequently resulted in current player's victory according to the previous playouts. Each round of Monte Carlo tree search consists of 4 steps. All right, well that sounds interesting. The efficiency of this method, called pure Monte Carlo game tree search, game search, often increases with time as more playouts are assigned to the moves that have frequently resulted in the current player's victory according to the previous playouts. All right. Selection. Start from the root R and select successive child nodes until a leaf node L is reached. All right. The root is the current game state, and a leaf is any node from which no simulation playout has yet been initiated. The section below says more about a way of biasing choice of child nodes that lets the game tree expand towards the most promising moves, which is the essence of Monte Carlo tree search. Expansion. Unless L ends the game decisively in a win or loss, for either player, create one or more child nodes and choose node C from one of them. Child nodes are any valid moves from the game position defined by L. Simulation. Complete one random playout per node C. This step is sometimes also called a playout or rollout. A playout may be as simple as choosing uniformly random moves until the end of the game is decided. For example, in chess, the game is won, lost, or drawn. Back propagation. Use the result of the playout to update information in the nodes on the path from C to R. Interesting. Okay. The graph shows the steps involved in one decision, with each node showing the ratio of wins to total playouts from that point in the game tree for the player that node represents. In the selection diagram, black is about to move. Okay? The root node shows that there are 11 wins out of 21 playouts for white from this position so far. It complements... Hey, what's up, is Matt? How you doing, man? It complements the total of 10 of 21 black wins shown along the three black nodes under it. Oh, the three black nodes under it, each of which represents a possible black move. Okay. Alright, so these are the possible scores for each of them. If white loses the simulation, all nodes... Alright, so it chooses the best one. Okay, so black wins. Okay, if white loses the simulation, I don't understand why this is being calculated for white. Right? Alright, let's try this again here. If white loses the simulation, all nodes along the selection incremented their simulation count, the denominator. Alright, so you got to here, selection. The current game state, and a leaf is any node in which the selection below says more about... I don't understand why it thinks I don't understand why it's choosing this as the most likely method. Wouldn't white choose the one that... Are all of these scores based on... Okay, I understand how we got 11 of 21. You add together... Oh. Okay. Okay, so this is the state we're in. These are the three different ways we can go. Black chooses the best one. White chooses... Why is white not choosing the best move for white? Right? Why is white not choosing the best move for white? The best move for white is very clearly this one. Okay? We'll come back to it. If instead white wins, all right, maybe it's, who really knows? Expansion. All right, so we chose this node for whatever reason. Expansion is we see that we're at now a leaf node L. And so we run a simulation all the way out to the end. And white lost. So we back that score back up to here. We back that score back up to here. Back that score back up to here. Back that score back up to here. Okay, all of those parts make sense to me. How we went from here down to here doesn't make any sense in the world. It's also not super clear to me why we only add one node here instead of like keeping all of the expanded nodes in the tree. Like, why would we not do that? But I guess it doesn't really matter. Okay. Rounds of search are repeated. Oh, wait, no, we should finish reading this sentence above. If instead white wins, all nodes along the selection would still increment their simulation count, but among them, only the white nodes would be credited with wins. Okay. That sort of makes sense. In games where draws are possible, a draw causes the numerator for both black and white to be incremented by 0.5 and the denominator by 1. This ensures that during selection, each player's choices expand towards the most promising moves for that player, which mirrors the goal of each player to maximize the value of their move. Rounds of search are repeated as long as time allotted to move remains. Interesting. Okay. This basic procedure can be applied to any game whose positions necessarily have a finite number of moves and finite length. For each position, all feasible moves are determined. K random games are played out to the very end, and the scores are recorded. The move leading to the best score is chosen. Ties are broken by fair coin flips. Pure Monte Carlo game search results in strong play in several games with random elements, such as whatever that insane name is. I can't read that at all. It's a board game. Okay, interesting. It converges to optimal play as K tends to infinity. In board games filling with random turn order, for instance in Hex with random turn order, DeepMind's Alpha Zero replaces the simulation step with an evaluation based on a neural network. Okay. Okay, I guess that's what we're going to do. Let's see here. We are in a thing. We are going to pull... Oh, we're going to... Oops, that one. Let's just do an old .NET new console. And let's call this... what are we going to call this? Monte Carlo tree search. I guess. Yeah, .NET. Let's just make a directory for source, mkdir source, cd space source. .NET new console Monte Carlo tree search. What the hell? Well, that's freaky. Why is that complaining? .NET new. Have I screwed something up here? You need to add in for the name. Oh. Ah, thank you so much, man. All right, Monte Carlo tree search. Program. Let's add a class called. Oh my. That was a really bad UI experience. You are missing assets to build and debug are missing. Yeah, sure. Don't ask. Yeah, whatever. Just do it. Okay, let's make a new file. I really like this breadcrumb stuff, by the way. It's amazing. Let's add in a new file. For some reason, this is giving me some hell. What is the matter? What have I done wrong? .NET Restore? No, we already had a .NET Restore. I'm really confused right now. Okay, I'm just going to restart it. For some reason, this happens way too often with code. And everything's fine. I think it got into a mode because I clicked the new button and then the pop-up came up and then it was just like stuck in that like not able to use it mode. Hey, what's up, Michael Jolly? Good to see you, man. Hope everything's going good. Woo! Feel free to lurk. That is totally allowed. Monte Carlo tree search. Okay. Namespace Monte Carlo tree search. Monte Carlo tree search. Public class Monte Carlo tree search. Okay. We're just going to leave this empty for now. Alright, so the way that we want to write this code is sort of like we static void play game. You know what we need to do? We need to implement tic-tac-toe. Let's not even worry about Monte Carlo tree search first. Let's implement tic-tac-toe. Right? That's what we want to do. Let's add in tic-tac-toe. Namespace Monte Carlo tree search. Oh wow, I didn't put that in the project at all. There we go. That was crazy. Now we want to say public class tic-tac-toe. What do you need for tic-tac-toe? You need a private. You know what? Let's make this a game. Why does it keep doing that? Game.cs namespace mtcs public interface I game. For a game, you have what do you have? You need to be able to tell whether or not the game is won or lost. You need to be able to expand successors. Let's start with that one. Okay, so we're going to have iGame array expand successors. Then we're going to have, so the idea is that a game is a representation of the state of the game. And when you expand the successors, you are making all of the possible next states that you could possibly be in. Then you need to choose one. Then you need to choose one. Is that really all you need? No, you need is terminal. Is terminal. And then you also want to know who wins. Who won. I guess we could just have it be like, yeah. Bool is terminal, and then we could just say out int winning player number. Something like that. So the idea is that you can ask it if it's terminal, and if it is terminal, then you can get the player that won, because we need to know who won. Okay, great. I think that's pretty good for that for now, and we'll just figure that out as we go. iGame. Implement that interface for me, please. Thank you. Appreciate you. Okay. So now what we need is a board representation. The board representation is going to be like private. Actually, I don't even really care if this is public. We can do it public for testing. And we'll just say let's do something like public enum tic-tac-toe player byte. We're going to have this be player 1, no, player X, and player O. Great. And then what we're going to do is have public tic-tac-toe player. Oh, wait. Nope, we need another one. Empty. And then we have tic-tac-toe. This is kind of... Let's do none. Okay, tic-tac-toe player, array, board, state, I'll just call it board. Get set. Okay, public tic-tac-toe. We're just not going to take anything in for this one. We're going to have this be board equals new tic-tac-toe player array. There are 9 cells. Great. Okay. So we now have a board representation. And based on the current player, I guess we're also going to do a public tic-tac-toe player current player's turn. And for the sake of argument, we're just going to say that X goes first. Oops. Tic-tac-toe player dot player X. And then the way that we're going to denote the end of the game is something like I guess public tic-tac-toe player winner. Okay. Winner equals tic-tac-toe player dot none. Okay, so to implement this, we're going to say this is winning player number equals int of winner. And then we're going to say return winner equals tic-tac-toe player not equals none. I also think for the sake of argument we'll make these pretend to be uneditable even though it doesn't really matter. And then we're going to say something like so we have we have handled the terminal case, and now we need to handle the expand successors case. In tic-tac-toe, you can move to any empty cell, and we need to create a game that is like apply move. So we'll have private tic-tac-toe apply move int cell number. And then what we'll do is we will say var successors equals enumerable using system.collections.generic. Enumerable is in system.collections. Using enumerable, what the damn? What the? Really? A generic? Quick fix. No. What is it in? Is it in system.link? Oops. Aha, found it. Enumerable.range 0 to board.length. And then we're going to say dot select, oh no, dot where m dot board of m equals tic-tac-toe player dot none dot select, and for this one we're going to do apply move, and then we're going to say dot to array, and we're going to say return successors. Okay, it's actually one of the link namespaces. Oh yeah, thank you so much, Coding Gorilla. I should have looked over earlier. Okay, so now all we have to do is do apply move. So we need to basically copy this var move, var next state equals new tic-tac-toe board equals this dot board dot to array. That will actually create a clone of the board state, and then we're going to say current player's turn equals this dot current player's turn equals so we just be really easy about it. I'm just trying to keep the code small. Equals tic-tac-toe player dot o, then it's tic-tac-toe player dot x, or tic-tac-toe player dot o, player o. Yeah, see, this is getting hard to read. You don't want that. So let's see if we can make this a little bit easier. Okay, and then we can say winner equals tic-tac-toe player dot none. And now the fun stuff is return next state. Now what we want to do is say next state dot board cell of cell number equals current player's turn. And then we want to say next state dot winner equals determine winner of next state. No, of next state dot board. Then we want private tic-tac-toe player determine winner of tic-tac-toe player array board, and at this point this can be static. Okay, and now this is just like gotta check all the cases. If let's do something really easy. Okay, let's do something like int array. So basically what I want to do is determine the winner from the previous move. Okay, if we check all of the possible ways that you can win, we're wasting a lot of effort because there are, you know, any given cell touches a maximum of 3 ways to win. But I think there's 1, 2, 3, 4, 5, 6, 7. There's 8 ways to win, so we can reduce looking at 8 things down to looking at 3 things. Yeah, let's not worry about that yet. For the time being, let's just private winning batches. Something like this. And then these are just private static read only equals new. And then we want new. And this is going to be 0, 1, and 2, right? So to do this, it's 0, 0, 1, 2, 3, 4, 5, 6, 7, 8 are the indexes. So what we're doing is we're saying that there's this one, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 ways you can possibly win. And 0, 1, 2 is one of them. 3, 4, 5 is one of them. 6, 7, 8 is one of them. Okay, 0, 3, 6, 1, 4, 7. 1, 4, 7, 2, 5, 8, 2, 5, 8. And then 0, 4, 8. And then 2, 4, 6. All right, those are all the possible ways that you can win. Now what we want to do is say for each var cell group in winning batches. Okay. If board of cell group, nope. Okay. Var possible winner equals board of cell group of 0. If possible winner equals board of cell group of 1, and board of cell group of 2, if possible winner not equals tic tac toe player dot none, and then return tic-tac-toe player. Well, no, return possible winner. Otherwise, return tic-tac-toe player dot none. Okay, perfect. So we now have a way to determine the winner. We now have a way to get all of these successors. Really all we care about is starting here. So we do this apply move. Apply move says create a copy of the board state, update the current player to have moved into that cell number. Since all of this happens under the hood, by the way, and we're generating all of the possible next states within this class itself, We don't need to worry about the validation step of like somebody modifying the state of this, because the only way to get a new state is to call this function expand successor. So as long as we validate that every single one of these that we generate is okay, then we're good to go. That makes sense. Okay. Tic-tac-toe. I think we're going to change this a little bit, and we're going to make this, instead of tic-tac-toe player, we're going to make this a little more generic, because I am going to want to, all right, player.cs. And what we're going to do is namespace mcts, and then instead of calling it tic-tac-toe player, we're going to call it player ID. And we're going to call it player 1 and player 2. And then we're going to go into here, and we're going to change all of these tic-tac-toe players to player ID. So clearly we're only doing 2-player games here. Probably a much faster way to do this. Oh, player 1, player 2, player 2. One. Tic-tac-toe player, 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 player. Okay. There we go. All right, so I think that's pretty much it for tic-tac-toe. Let's go ahead and make it so that we can play against it. Just call this player ID. Rename. Okay. Now we're going to make something called human player or console player. And why do I keep doing that? I keep putting it in the wrong folder. I'm just really bad at that today. Namespace, this namespace, public class human player, oh, console player. Okay, and now we're going to need, okay, we will change this back to player rename. And then we're going to put in a public interface iPlayer. And the way that this is going to work is you are going to be asked to make a move. Okay? iGame make move. And you are given an iGame current state, iGame successors. And I guess we'll give it a name as well. Or how about a player ID? Player ID. Now we don't need a player ID, we need a name. String name. Good. Okay. Probably. Okay. And set maybe? Whatever. Who cares? We'll come back around to it. Alright, so console player is an I player. And now, what I want to do is implement this interface. Why is that even like that? That's so silly. What a silly way to do that. Really weird. Whatever. Okay. And I'll just do public console player. Like that. And then the make move thing. Alright, this is the fun one. This is the fun one, and now let's go something like dictionary. I don't even need a dictionary. Let's do something like public, or sure, whatever. Public string display public static string get board representation. That's, I guess all of a sudden you need this representation to be part of the actual. Okay, let's do tic-tac-toe. Tic-tac-toe. Okay, board. Current state. Alright, state. Okay. Now we're going to say tic-tac-toe state. State dot board dot select m equals no, m equals tic-tac-toe. What? Oh, equals player ID. Player ID dot none. Then we'll just leave it as a space. How about for int I equals 0, I less than 3, I plus plus, string result equals that. Okay. For int j equals 0, j less than 3, j plus plus, return result. We want result equals, no, plus equals Okay. Private. No. Using system.collections.generic dictionary player ID to string representation. Rep equals new dictionary. Okay, rep. I think you can actually do it like this. And then you can do it like this. And then you can say player ID dot none space player 1, player 2, X, O. Okay. Now you can say result equals rep of, no, equals empty string. Then you can say this equals rep of I times 3 plus I times 3 equals rep of state.board. Our board equals state.board. So I'm just going to type this quite a bit of times. Board of this. And then I can say plus J equals plus, and then I want a, and then I want result plus equals a dash, a plus, a dash, a plus, a dash, if I is less than 2, then do that. Okay, this is a really super hacky way of going about this, which I'm a little embarrassed of, but whatever. We'll deal with it. It doesn't matter. The whole point here is to like just get this thing so that it can make a state, so that it can make a representation. We're going to go slash in, slash in. And then I need result plus equals slash n. That's correct. I guess I could do this up here, and then it'll actually look like it's part of this. Okay. Let's just do it like that. Okay. So now what we want to do is we want to say console, nope, using system, I think it is, yeah, using system console.writeLine, please choose a move. Oh, wait, current state. And then console.writeLine of current of get board representation of current state. And there's a way to do this dynamic. Okay, that is also a really big hack, but a fun one. Okay. And then we want to actually write out console.writeLine. Please select a successor. And then I'm going to do something like I'm going to add something really, for the sake of getting it done, we're just going to have something like I just don't know an easy way to do this with keeping the concerns separated here. Like, I don't want to put information about what the last move was in here because the last move is a chain of these I games. But I want to make it really easy to choose it without having to like blow up the console and show a bunch of states. But that's just what we're going to do. For int I equals 0, I less than, and this needs to be an array. Duh. Player, successors, array. I less than successors dot length, I plus plus. We're going to say console dot write line yep, and then we're going to do console dot write line of successor get board representation successor dynamic of successors of I, and then we're going to have int selection equal, we're going to do int selection equals -1 while selection is less than 0 and selection, I guess this has to be a string, and selection is greater than or equal to 0. No, is less than 0 or greater than. Selection is greater than successors dot length greater than or equal to var input equals console dot read line try selection equals int dot parse of input catch whatever try again. I guess we can do it like this. Whoa. Ah. Try again. Alright, this is horrible. I honestly am not like a person who is good at doing this sort of thing. Return successors of selection. I'm not a... Yeah, I'm just like, I don't know the right way to go about this. I'm sure there is a much better way. I just... not super interested in it right now. Just want to get to a working state so that we can get to the more interesting parts of actually doing the Monte Carlo stuff. Okay, so we now have a player. Let's create a program, play game. We're going to have this be play game. And what we're going to do is we're going to say var state equals new tic-tac-toe. And then we're going to say var player1 equals new console player. Name equals player1. Player2. And then we're going to say something along the lines of while not state.isTerminal out. Oh, we need to change that. Player ID winner. So iGame, this is player ID. Great. Tic-tac-toe player tic-tac-toe player ID winner. Make sure player 2's name is right. Otherwise, player 1 will always win. Oh yeah, good call. Solid choice. Oh, better way to do that. Name of player 1. What do you mean I can't do that because I'm defining it at that time? That would be way too cool, wouldn't it? That's stupid. It's name of. It's like a static compile time thing. That's really frustrating. Player 1 it is. Okay. Var current player equals. Yeah. Let's do player lookup. Let's do using dot collections dot generic var player. Why am I doing this the hard way? I just feel like I'm really doing this the hard way. Var player lookup equals new dictionary of player ID to iPlayer. And we're going to do player ID dot player 1 goes to player 1. Player 2, player 2, current player equals player lookup of state dot player dot current player's turn. Okay. Var we're gonna just basically update this. State equals current player dot make move of current move of state, and state cannot implicitly convert iGame. Okay. Okay. Oh, we need to add that to here. So tic-tac-toe, current player's turn. Is terminal. Player ID, current player's turn. Okay. And then we can at the very end say console dot write line the winner is Garrett Wow account. If you don't mind repeating yourself, probably, what are you working on? I see that you are coding a Monte Carlo tree search algorithm, but what does that entail? So currently what we're doing right now is actually making a game, a really simple game, tic-tac-toe, that we can then apply Monte Carlo tree search to. And we're at the point of like trying to finish up the actual like playing logic so that we can play an example game. And then we go straight into implementing a Monte Carlo player. That's sort of the goal here. All right, the winner is plus player lookup state dot current. Ooh, that's not going to work. Winner. Okay. Dot name. And we're going to say if. Oh, I don't have winner. That would have been way too easy. Player ID winner. Okay, if winner equals player ID dot none, else console dot write line of the game was a tie. And then that's it. Okay. let's see where we're at with this. If we do this play game, it appears that everything we need is here. We go to the console player. I almost feel like I this is fine. Make move needs some way to extract the representation from the game. Okay, it doesn't really matter. Let's go ahead and see if this works. cd space src.net build cd space mcts.net build .net run Oh, this is exactly what I was talking about. Look at how long this gets. All right, the current state is this, and we need to choose a successor. So we choose to play, I guess, in the middle. So we'll choose 4. Then we scroll all the way up. We see that that's the current state. Please choose a successor. Wow, we're going to have to like really expand this here. If I was player 0, there's really only 2 interesting places, 0 or 1. So for the sake of argument, we'll just choose 0. The current state is this. I guess we'll choose something that is more likely to win. So we'll choose 5. Okay. Then we'll choose. I'm trying to just like, I guess it doesn't really matter here. The goal is just to see if there's a winner, right? Kind of silly. Hey, the winner is player 2. We didn't output the resulting state. Tic-tac-toe. Program. Shrink this back to where it was supposed to be. Should we just get rid of it altogether? Okay. Console.writeLine. The game is over. Console.writeLine. Console player dot get board representation of state dot of state dot what the damn get board representation. Oh, that's right, you got to do this dynamic. Okay, and then we print out the final state, and then we print out the winner. Okay, I feel okay about this. One last thing I wanted to do is on the console player, I wanted to put a note in here, which is console.write. Please enter your selection. Okay, let's try that. No, not what I wanted. Okay. All right, so we now have a game higher up. Right. Right before the input. That's right. Okay. So we now have a game that can be played, period. And magically, I had like only one bug. I had 0 bugs. It just compiled on the first time, didn't it? That was kind of cool. Then let's say .NET Run. Let's just try this one more time. All right, we're just going to go with 0, and then 2, and then 0, and then 2, 1, and then 0. Hey, all right, please enter your selection. The game is over. X1. The winner is player 1. Okay. And then let's do something like, let's just have player 0 win. 0, or player 2 win, rather. And then we want 3. And then we want 0. And then we want 0. And then we want 0. And then we want 1. Okay, alright, hooray. Player 2 is the winner. Go player 2. Now we need an actual tie. Okay, just to like verify all of the logic here. 0. There's an easier way to verify this logic, of course, which is to write a test. I'm just not feeling that right now. 0, 0, 0, 0, 0, 1. Oh, I can't prevent. That was dumb. Yep, that was dumb. 0, 0, 0, 0. Nope. Yeah, I have to finish it now. Okay, there we go. It's 0, 0, 0, 1, 0, 1, 0, 1, 0. Uh-oh. See? This is why we do this. Right? Because I can't get out of this loop now. I'll be stuck in this loop forever. Okay. So the problem here is my logic for determining whether the game was won or lost was entirely due to this is terminal check being invalid, which is going to come down to the actual game itself. Tic-tac-toe. This is invalid. I need to basically verify that there is at least one open cell. No. What I need to do is say, and current player's turn not equals player ID.none. And then I need to correctly set current player's turn to none when we're out of cells. Hey, what's up, World Wake? I hope you're having a really happy Friday. Okay, so let's set the next player's turn to none. In the case that we're just going to ignore this altogether. We're going to say board, nope, next state. Okay. So let's say if all right, I need to actually update this first. Then I need to say if next state.any using system.link. I am using system.link. .board .any m dot m equals player ID dot none, then there is a next person's turn. Else next state dot current player's turn equals player ID dot none. Okay. Let's go to current player's turn. Okay. Doing great. Got some good ideas for what to start working on next in my free time. That's awesome. Yeah, I don't have a Bang project. That's something I should get set up. I will put that on my to-do list right now at this very moment. Add Bang project to stream elements. Good call on that. Yeah, there's like so many things. I wish there was like this like developer dashboard that you just downloaded, and like as a developer all of these things were just like, okay, look, you just got to fill all this crap out like 5 minutes before you do the show, and then it works. And that would be awesome. Okay, let's try this one more time. We need an actual tie now. And then all right, 0 0 0 0 0 0 0. All right, player 1 won. Hooray! 1 0 0 0 0 1. Ooh, all right, player 2 won. All right. 0 0 0 1 0 1 0 1 0. Ugh. Really? Where are we at? Line 26? Line 20. Wait, what the hell? No. Console program. Line 26. If state.isTerminal, at this point I'm like, we're just going to write some tests for isTerminal. Is terminal test. Okay. Uh, if it is terminal, which I need to go to tic-tac-toe. If it is terminal, is determined by the winner. Oh. That doesn't have to be true. This is an or. Or current player's turn equals none. And since that one happens way more often, we're going to put that first. Whatever. Okay. Now, if I want to check if a state is terminal, I need a way to spin up a terminal game. How the hell am I going to do that? I want to set the board state. Well, luckily, the board state is public. Okay. Var state equals tic-tac-toe. New tic-tac-toe. Okay. And then I want to say state dot, and this is where I want this to be public. Apply move. Oh wait, why don't I just test this, right? Give me just a moment. Everybody take a break for a second. I'm going to get up and walk around because my watch is going off. I'll be right back. All right, and I'm back. Okay. What is the free time I keep people hearing getting? That's the truth. Okay. I want to test this apply move. Then I want to test is terminal. Okay. Var tie game equals new, and then the moves are 0, 1, So 0. Oh, okay. Wait. 0. 3, 1, 4, 5. And that should be okay. For each tie game, for each var move in tie game, state equals state.apply move tie game. Move. If state dot is terminal, player ID, winner. If not state dot is terminal, out winner, throw new exception, should have been a tie. If winner not equals player ID dot none, throw new exception, expected winner of tie game should be none. Okay, then we're basically just going to do this over and over and over. Okay, moves, tie game, player 1, player 2, this is not a tie game. This is player 1, 2, 2. This should be a player 1. Name of player ID dot player 1. Let's just do something like player ID expected equals player ID dot player 1. Expected. The free time is very confusing. We have to be responsible for how we use our time, and if we're not working on becoming better programmers, we're slacking off. Absolutely not. Man, in your free time, you need to rest. That's what it comes down to. Fuck that. Everybody who says you need to spend all your free time continuing to learn how to code, like, you don't. You need to get your rest, and you need to learn other stuff too. Expected. expected. Okay, that's player 1. Player 2. And this one will be none. Alright, so how do we make it so that player 2 wins? Simple. Put 6 and 3, 4, 5 like that. But I'm watching some dude program on stream right now. It's like the last thing I should be doing right now. Well, so this stream is like not super intended to be like an educational thing as far as like you sitting down to like learn some stuff. This is more of an entertainment exercise. The stuff that I do for learning is like when I write a blog post, right? So like I wrote a blog post recently, and that is where you would go to like look at how, you know, this is when I want you to learn something. I am producing content like this. Edutainment, I like that term. That's a good one. Do we call it edutainment? I would absolutely call it edutainment. Like that's the goal here. Like feel free to talk about whatever you want. Feel free to lurk. You know, if you want to get involved with what we're working on, that's totally cool too. As far as like education goes, this is really my education at this moment in time. I am learning how to do Monte Carlo tree search. I am not learning anything else. Don't want to be in there. But yeah, I hope it's entertaining. Like that's my goal here. If it's not, let me know, man. I will try harder. I will talk in weirder and weirder ways. Okay, now we need a game that is a winner for nobody. This needs to be... Here's a great way to do it, which is 0, 1... No, 0, 1, 2... 3, 4, 3, X, O, oh damn it, X, O, X, O, X, O, X. Okay. So that's my first row. My second row is X, O, and I want it to be an X. So I'm now going to put in 5, 3, 4, 5. And then my third row is going to be OXO, 6, 8, 7. And I believe that is what I'm looking for. Might need to update your headshot. Looking much slimmer and fitter now. Wow, I appreciate that. I really do. I've been working at it. I got this like watch I started running. My wife is actually a Beachbody fitness coach. And she's like been on me about it for a long time to like get into it. It's like I support her all the time, but working out for me is not something that has been a to-do for a very long time. Yeah, basically, cut me some slack. I can't do that shit you do. She is literally outside my window right now, working out on the back deck, because it's like a really nice day here. It's like, as soon as I get off of this stream, she's going to be like, you need to get out here. You need to do this. Go for a run. I'm like, I'm at work. She's like, You need to work out anyway. You need to make yourself a priority. I'm like, damn, you're right, I do. Yeah, since school has ended in May, I have lost about 15 pounds in the last like shit 2 months. Like the stress level of being in school was through the roof, and it really showed. Like there were so many nights where I would just go and get. I don't actually have a Discord. If you want to get a hold of me, Twitter is really the best way. I am on plenty of other people's Discords around here. If you follow the Live Coders team, there's a bunch of them like C Sharp Fritz, Clark EO, uh, Lana, Lana Lux. I'm on a lot of their Discords, but damn, I'm really bad at this. I don't have any of this. Just go to my website. Yeah, just go to my blog and like, there's links to all my crap on there. Yeah, I have like so many things about the actual like design of the site of the stream that I really want to work on. I just haven't really gotten around to it. Okay, I'm gonna get these tests going, and then I'm really running out of time for today, which is kind of a bummer because I was hoping to get some actual Monte Carlo stuff done. I mean, it's just random, so it seems like it shouldn't have been that hard. Let's test these. This should have thrown. This should have thrown. This should have thrown. Yeah, let's test these. Is terminal test. All right, so in the case that any one of these doesn't show to be my expected output, I will know. I will know that this is not it. Each one of these should be terminal. In this case, player 2 wins. In this case, player 1 wins. Okay, let's try this. Oh. Ah. There we go. That's what I really wanted to do. If the current player's turn is none, then the game is over. That's it. Okay. Let's try and run this. Hopefully it doesn't fail. Damn, it failed. Should have been player 1. Okay, great. Let's go to line 26. Control, click. Should have been player 1. Actual was plus winner. Build it, blow it up. Should have been player 1. If state.is terminal, if it's not is terminal, so somehow it thinks this is not terminal. Oh. Oh. Okay. Okay. We apply the move. Determine winner. determine winner only takes the board into account. So I can do it like this. Then I can say if next state dot winner not equals player ID dot none, and there are any moves remaining, then we set the next player's turn. That makes sense. Let's try that. Okay, and in this case it wants to actually play a game, so we finally passed the test. Hooray. Okay, great. Okay. Cool. Yeah, just for the sake of time, like, because I do have to go today, I am going to wrap this up. And that's going to be it for today. Our state is passing, and then we get to just move into the Monte Carlo stuff starting tomorrow. I said tomorrow. What I meant was the next time we're here. Okay. So that's it. So let's go find someone to raid. It appears that... Who is raiding? Who is running? Okay, let's do C# Fritz. That's the one. All right. I would like to thank everybody for joining. I hope it was entertaining. That's what we were going for. And I will be back on Wednesday. My schedule is about to get a whole lot more consistent, largely because a lot of really big projects at work all just got wrapped up and things are dying down, and I'll be on vacation a little bit in July, which is going to be awesome. So I should have plenty of time to stream in the next few weeks. And our normal stream times are Wednesdays, Thursdays, and Fridays from noon until whenever I quit, which is normally about 2 to 4 hours. Thank you again, everybody, for joining, and I hope to see you all soon. Expect also, check out and make sure you check the blog sometime Monday, Tuesday. I'm going to have a new blog post out continuing on the work that we did on the decision tree performance improvements. This one is going to be a lot more fun, a lot more technical, and there's going to be some actual improvements here other than just rewriting everything in C#. So again, thank you, everybody, and I will see you all soon. It's going to be like 10 seconds. Then we're going to go over there and we're going to raid C# Fritz. If y'all haven't seen his channel, it is a lot of fun. There's normally a pretty good chat going on. And yeah, just have a good time. See you soon.
The server's about to restart. I should probably log off. Let the server restart. Yeah, there is. And I'm not afraid to say that going and checking out the kittens channel and the chickens kind of give me life.
That was weird.
Alright, I don't log off because the server's about ready to restart. I So I'm going to go run to Little Girls, get some coffee, And
Hey, what's
NetSkills says, dang, $40 for a font. You're absolutely right, NetSkills. However, there's a lot of people that use a font called Operator Mono, which is one that I like. However, that's $200 minimum for that font. So I was like, this is a good compromise. Yeah, Operator Mono. There you go. That's what we just talked about. Check out Operator Mono. Next question. Whenever I have a problem with JS, I call Marathon. Will Bennett says PG is the answer to that joke. I like it. Robert Taylor says, I have it and I love it because I'm bougie as heck. That's cool. Hey, to each their own, Robert Taylor. I would like to have it. Happy Friday to you as well, Nick Larson. Good to see you. How are things by you, man? And then Nala shared there should be underscore prop top or okay. We gotta do that way. You're saying that equals session data. This equals files, and then default to an empty object. That would work too. But then I have to inject this like this, right? I'm worried that this is only going to work for the test, and it's not going to work when I actually do it. Can you give me some confidence in this? Yeah, that looks good. So what you're saying is this. Let's make sure we understand this. Oh, okay. I think I see what happens. So if there is if an object gets passed in as this parameter here, after event, then it will deconstruct it like this. Or it will deconstruct it to where there's session data and files. If there is not an object, we default to an empty object, and we just say that we're going to default files to the internal files of the session data. Is that correct? That's in response to what. So Nala, am I understanding that correctly? Yeah, that's correct. Awesome. Thank you so much, Nala. Shout out to Nala for teaching us that today. Mark that moment in time too as well. We can refer back to that later in the stream notes. So a little more advanced object deconstruction. Talk to me, Guzman says Nala, the knowledge bala. Will Bennett says deconstruction is cool. It is, right? That way I don't have to keep doing. Otherwise, I would have to have it where it's like function, event, and session data, and files, and whatever else, yada yada yada, over and over again, right? So knowledge is saved if we have to do that. So I was looking into how to get operator mode licenses. Ooh, I'll take this. That's pretty expensive. Yes. Boom! Thank you so much, Ardalis, for the raid. Welcome, everybody, from Ardalis' stream. Dude, you're so kind. You're always raiding us. I appreciate that continued support from you. Hope your stream went well. What were you working on, Ardalis? And welcome, everybody, from Ardalis' stream. My name is Brian Clark, a.k.a. Clarkio. Happy to have you here. We do a lot of JavaScript and Node.js development. Today, you can use the today command, exclamation point today, or exclamation point project to learn more about the project and what we're doing today. We're doing a unit test, basically. And that's what's going on. Ikoa, my man, my friend. 5 months. Holy cow. Ikoa says, hey. Just dropping us something saying, hey. I love it. Thank you so much, Ikoa. Appreciate the continued support and happy to have you on this team.